Welcome to our review for Unit 5. Unit 5 is on writing classes and also on static fields and methods. So to start with writing a class, there's three parts. There's the fields, then the constructor or constructors, and the methods. So starting with our fields, these are the properties of the object. And when you create a field, you create a has-a relationship between that field and the class. So it should make sense to say the class has a and the field. So for example, cookie has a type. That makes sense to say, so we can create a field called type. Same thing with ingredients. A cookie has an ingredients list, so we can create a field for the list of ingredients. So we want our fields to be private, so we always write private here. The only exception to that is if they're both static and final, then you can make them public. You probably won't be writing any static final fields, but you do use examples of those. So in the math class, for example, there is a public static final field called pi. That represents the constant pi. But usually when you're writing a class, you're not going to have your fields be static and final. So we create those private, and that limits the scope of those fields to just be in that class. So if you have maybe a colleague who is working on another class that's using your class, they can't access those fields without using an accessor method. So you get control over how those field values are changed. All right, the second part is the constructor. The constructor is what creates the new object. So whenever you want to create an object, you have to call the constructor. It sets aside the memory for all of the instance variables, so the non-static fields, and it sets the initial values for those fields. You don't have to write a constructor. If you don't, there's going to be a default one that the Java compiler puts in for you called no args constructor. So no arguments, no parameters constructor. And all it does is it sets aside memory for those instance fields, and then gives them the default values. So numbers, it's 0, Boolean, it's false. For all objects, it's going to be null. The name of your constructor, if you write a constructor, it must match the class name exactly. Capitalization matters. And a constructor cannot have a return type, so not even void. So to write the constructor declaration, you write public, the name of the class, and then in parentheses you put any parameters. That's it. So here is an example of a very simple basic constructor for our cookie class. So you can see public, there's no return type here. And then cookie, this matches the name of the class. And I chose here to make this be the no args constructor. So whether I write this or I don't, so if I excluded this constructor, the class would be exactly the same. This is the version of the constructor that Java will put in by default if I don't write one. Now if I do write one, then Java will not put in this default constructor. So we only get it if we don't write a constructor. All right, so here's a little bit more involved example. So again, I have public cookie. We have to have that as the beginning of our constructor declaration. But this time I've added two parameters. So an array of strings for the ingredients and another string for the type of cookie. And then I'm using those parameters to set the value of the field. So the ingredients is going to get whatever is in this array of strings, and the same thing with the type. Now, back in example 1 where we didn't have parameters, we still have values for our fields because there's memory set aside for them, so there has to be something stored in that memory. So for the array of strings, it's just null. It doesn't even have a length. There's nothing there. It's just null. And then for the type, since that is an object, string is an object, that's also null. All right, so this time we're giving the fields values. Example 3, this is really similar to example 2. We have the same parameters here. But this time, instead of setting ingredients equal to the parameter, I'm copying everything from that array into the ingredients array. So if we later changed this array somewhere else in our code, it would not change what's in the ingredients field. So in example 2, since we are setting these equal to each other and it's an array, we know an array is just a memory address, then if we changed what's at the memory address, it would change both the parameter and the field. Whereas here, we're actually making 2 copies. So now we'll have 2 different memory addresses for different string arrays. We've got our original one, which we're not changing. That was passed as our parameter. And then we have our ingredients field. So we're setting aside new memory for that here, and then copying into that new memory all of the ingredients from the parameter. And then we're also setting the type. So that's the only difference, is we're just making a copy of the array instead of setting it equal to the original array. In our next example, this is very similar to example 2, where we've got 2 parameters and we're setting our fields equal to those parameters. But the only thing I've changed here is the name. So I've actually made the parameter names be the same as the field names. So in order to now differentiate between the parameter and the field, we have to use this dot. So if I write this dot ingredients, that is referring to the field called ingredients. If I just write ingredients, that's referring to the parameter called ingredients. So we have to use this dot here so that we can set the field equal to the parameter. Back in the other examples, we could have used this dot. So I could have written this dot ingredients equals new string. It's not required here because I only have one variable called ingredients, so there's no possibility for confusion. Over here, there are 2 variables called ingredients, so I have to use this dot if I want to reference the field. Same thing with the type. This dot type is our field, type is our parameter. All right, and yet another example of how we can do the constructor. So we again have public cookie. We've got our 2 parameters here. This constructor is what we just saw in the last example. But now I have a second constructor, and we can do this. We can have as many constructors as we want. They all have to say public cookie, so public name of the class. But then as long as we have a different number of parameters or different type of parameters, so maybe an int, or if we wanted to have 2 parameters, we'd need something other than a string array followed by a string, then we can have multiple constructors. So we overload the constructor. And in this case, we are setting just the type in the second one, so our ingredients list would remain null. So the way that we differentiate when we're calling the constructor is when we type in the parameters. If we type in just one string, it's going to run this version of the constructor. If we type in a string array and a string, then it will automatically run this version of the constructor. All right, moving on to our methods. So our accessor or our get methods, these are what let us access the value of a field from a different class. So remember, our fields are private, so we cannot access them from a different class. So we have to have accessor methods. And in some cases, maybe you don't want other classes to know the value of those fields. Don't write an accessor method, and that will take care of it. But if you do want another class to be able to access the value of your fields, you're going to write your get method, your accessor method. It's a public method so that other classes can call it. The return type should match the data type of the field that you're writing it for. So since we're writing get type, type is a string, my return type is also a string. And then these are usually just one line of code, return and the field. All right, our modifier methods, these have 3 names, but it's all the same thing, whether it's a modifier method, a mutator method, or a set method. Mutator methods are what we use to update the value of a field. And they're usually void, although sometimes they might return a value to indicate that it was updated. And they usually have a parameter for the new value. So in this example, we are writing a mutator method for the ingredients field. So we call it set ingredients. It's void, it's not returning anything, it's just updating a value. And we have this parameter here called ingredients, and it contains the new ingredients. So we're changing what ingredients is. And I'm using this dot ingredients to reference my field and setting it equal to the parameter. All right, moving on to static fields and methods. So far we've been talking about non-static fields and methods, also called instance fields or instance methods. When we have this modifier static, it means it belongs to the class, not an object. So if we have a static field, it does not belong to any specific object. In fact, you don't even need to make an object of the class in order to have a value for that static field. If you do have objects of the class, that's fine, but they're all going to have the same value for that field because the field doesn't belong to any one of them in particular. It's the same for everything in the class. Same thing with those static methods. They don't get called for specific objects, they get called for the whole class. When you write a static method, you have to be careful that you can only access and modify the static fields, not the instance fields. So since a static method doesn't work on any particular object, you can't access those fields that have different values for different objects. So you might be wondering, why would we want to do this? Static fields are really useful for constants. So remember in the math class, we've got pi, we've got e. Those values don't change. They're always the same, so they're static. They're also useful for keeping track of how many objects in a class have been created. That can be useful in and of itself, but it's also useful if you want to create unique IDs for each object. You just keep track of how many objects you've created in that class and just give each one an ID that's one greater than that. So here's an example. If we have a dog class and we need to keep track of the name of each dog and also the ID. So maybe all these dogs belong to a shelter and they have specific IDs that go with them. So we're going to have to keep track of the IDs that have already been used. So the next ID is going to be the ID that we're going to assign to the next dog that comes into our shelter. And then we also want to make sure that their names don't get out of control long. So we're going to say that we can only have 25 characters in the dog's name. So in our constructor, we have a parameter for the name. And before we set our field equal to that parameter, we're going to do this check. So if the length is less than the max name length, then we'll set it, otherwise we won't. And then for the ID, we want each dog to have a unique ID. So we're going to set the ID, which is an instance field, equal to next ID, which is a static field. So the first time we call this constructor, ID will be set to 1. That's our initial value up here for our static field. But then we increment next ID, so next ID will be 2, and the next time we call this constructor, our ID will be set to 2, and then we'll increment it to 3, and so on. So constructors and instance methods can access and modify static fields, just like we do right here with next ID. But if we were to write a static method, we could only access and modify those static fields. So for example, if we wanted an accessor method for next ID, we would write public static and get next ID. If you left out the static, it would still work because a non-static method can access a static field, but it would be a little bit odd because that would require you to create a dog in order to know the next ID. Whereas if you made it static, you could call it with dog.getNextID. All right, so that ends our video on classes and objects and how to write a class with your static fields and methods. And again, not all classes need to have static fields or methods.